Okay, this is page 6, non-algebra method version. So the thing about the non-algebra method is you should have plenty of paper. So use like a whole piece of paper for each problem. All right. So we're going to do this one here. So I copied this problem, x minus 3 over x squared to the 9th above, and we're looking for the constant term. Okay, and we are going to write a whole lot, but just enough to be smart. Okay, so do you remember the template? So pretend you're using the template, but since these numbers are really big, I'm not going to use the template itself. I'm just going to write out a whole bunch of stuff, okay? As if I was using the template, but you've used this template so much that you kind of know what it looks like, right? So first thing I'm going to do is I'm going to write out the numbers from 0 through 9, and then you'll see in a second what I'm doing here. Okay, so and I did a terrible job of making them evenly spaced, okay? And I'm going to make these into the Pascal's triangle coefficient. You see what I'm doing here? If I do 9 chooses 0, 9 chooses 1, 9 chooses 2, these are the Pascal's triangle coefficients for all the terms. Okay, now maybe I don't need to finish them all, right? We're looking for the constant term. So once we find the constant term, we're just going to abandon the rest of the work here, okay? Let's change the color. And now what we're going to do is going to put all the x's, we're going to put all the triangle x terms, and we're going to start counting from 9 down, right? So x to the 9th, x to the 8th, x to the 7th, x to the 6th, x to the 5th, x to the 4th, x to the 3rd. Maybe we don't need to go all the way. Okay, and then let's do the b term. The b term is negative 3 over x squared to the 9th. Okay, now, for now, let's see. Yeah, I'll put the x. So I'm not gonna write the negative 3 for now. Okay, I'm just gonna write the x squared in the denominator. Okay, so I'm gonna put x squared, x squared, x squared. The reason why I'm only putting the x squared is because once I figure out which term is actually the right term, then I'm going to develop it completely, but I only need one of the terms, right? The pen's freaking out. Okay, and then I'm going to put the exponents, which are 0, 1, 2, because I'm counting up, right? 3, 4, 5, 6. Okay, and let's see if we can figure out which term it is. Maybe we've already written it. Maybe we don't need to go all the way to the end. Let's see, x to the 9th divided by x to the, I can't even read my writing, it's 0, right? X to the 9th divided by x to the 0th is x to the 9th. So it's not that term. X to the 8th divided by x squared is x to the 6th. That's not that term either. X to the 7th divided by x to the 4th is x to the 3rd. Oh, we're getting close. And you can see the pattern here. 9, 6, 3. What do you think the next one's going to be? 0, right? X to the 6th divided by x to the 6th is x to the 0. We found it, and we only needed to do the first few terms. Okay, so 9. Oh my God, the pen is freaking out. Sorry. 9 chooses 3, x to the 0. And then now we can write out the rest of it, which is, okay, I'm going to write it here, bigger. 9 chooses 3, right? X to the 6th is the a term. And the b term would be negative 3. Now that I'm writing out, now that I'm going to really expand it, instead of just writing x squared in the denominator, I'm also putting the negative 3 there because that's super important, right? And the b term exponent is 3. Now we're almost home free, right? So let's just simplify this. So 9 chooses 3. We can use the calculator for that. 9 chooses 3. Oh, what do you know? I already did 9 chooses 3. So 9 chooses 3 is 84. 84, x to the 6. Negative 3 cubed is negative 27. Divided by x squared cubed. X squared cubed is x to the 6. And what do you know? The x to the 6 cancels out, giving me the constant term. Yeah, that's what we had figured out. By the way, 84 times 27, I did that before. It's 2268, so it's negative 2268. So our constant term is negative 2268. All right, how was that? No algebra. Okay, now we're going to do the next problem, which is x plus 2 over x squared to the 15th. We're going to find the constant term of that, not using algebra. This is the non-algebra method. If you prefer to use a little bit of algebra, maybe a lot of algebra, go watch the other video, okay? All right, this is for people who don't like to use algebra. All right, so same thing. We're going to start by doing our Pascal's triangle coefficients. 15 chooses 0, 15 chooses 1, 15 chooses 2. Okay, so it's like we're using the template, but we don't have the template here. Seven. Okay, I'm going to start taking shortcuts. I'm not going to write the 15 anymore. We don't need to we just need to have placeholders for everything, right? Okay, and probably the thing is kind of in the middle, so we're not going to go all the way to the 15th term. All right, and then so that's our Pascal's triangle coefficient. The next element is the triangle, the a term, x to the 15th, x to the 14th, x to the 13th. Be careful not to mess up here. So the weakness of this method is if you're disorganized or messy or careless, you're dead. On the other hand, if you're any of those things, the algebra method, you're also dead. So you just, I mean, if you're messy or careless or whatever, you just are going to do bad on this unit. I'm sorry. Okay, 2 over x squared is the other term. And first, we're only focused on the x's because we just want to know when the x's all cancel out and we get a constant term, right? So we're going to ignore the 2, and we're just going to think about the x squared. So we're just going to put x squared for each term in the denominator, of course. And we put it in parentheses because in a second, we're going to apply the powers. And you might think, oh my God, this takes so long, but actually the algebra method also takes long. And the key is use a method where you're going to get the right answer, right? And if you look at the length of the videos that are algebra method and not, they're about the same length, and I do the whole problem. Okay, and so this is to the 0 power. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm basically doing the whole template, but a little bit, taking shortcuts, right? Like I didn't do the last terms. Okay, now I'm going to see the pattern here. So x to the 15th divided by x to the 0, because 2 times 0 is 0, is x to the 15th. That's not a constant term. X to the 14th divided by x squared is x to the 12th, not a constant term. X to the 13th divided by x to the 4th is x to the 9th, not a constant term. X to the 12th divided by x to the 6th is x to the 6th, still not a constant term. Now you can see the pattern. X to the 15th, x to the 12th, x to the 9th, x to the 6th. What do you think the next one's going to be? Yeah, x to the 3rd. What do you think the next one would be? Ah, the constant term, x to the 0. So x to the 10th divided by x to the 10th is x to the 0. So now we found it. Now that we've found it, we can develop it completely. So 15 chooses 5 is the Pascal's triangle coefficient. X to the 10th is the a term. The b term is 2 over x squared to the 5th, right? To the 5th. So now we just need to simplify a little bit. 15 chooses 5. What is that? Let's check the calculator. Oh, I already did it before. It's 3003. 3003, x to the 10th. 2 to the 5th, that's 32. You can do that on the calculator. X squared to the 5th, that's x to the 10th. Oh yeah, these cancel out, right? Those two cancel out. So I'm left with 3003 times 32. Oh yeah, that's 96096. And I'm done. The constant term is 96096. How do you like that? No algebra. Okay, let's do number 7a. Find the coefficient of x to the 5th in the expansion of this here. Whoa. So when we did a problem like this in the past, we did a complete expansion of this to make it easier, right? And then we use lattice multiplication with the binomial. This time, in principle, we still want to do a complete expansion, okay? But as we do it, we'll see that you don't really need to develop the whole thing, okay? So I'm going to go ahead and do it here instead of on the template. You guys are pretty used to following the format, right? So I'm not going to put the Pascal's triangle coefficients. I'm just going to put the 8 chooses 0, 8 chooses 1, 8 chooses 2, and so on, okay? Okay, and then it goes to 8 chooses 6, 8 chooses 7, and 8 chooses 8, and that's the end. All right. And we're only going to need a couple of these, and we're going to see which ones they are in a second, okay? These are the triangle terms, or the triangle expressions. Let's put the circle expressions. It would be x squared, x squared, x squared, x squared, etc. And then the x squared is taken to the power of the 8th, 7th, 6th, 5, 4, 3, 2, 1, 0. Okay. And then the square term would be the 1, and it would be 1 to the 0, 1 to the 1, 1 to the 2, 1 to the 3. Oh, but 1 to the 0 is 1, 1 to the 1 is 1. So that doesn't affect it. So we're kind of done. We don't need to put the b term, right? So here's the whole thing, all right? Now we're going to see how we can be a little bit smart about this. Okay, so now what we want to do is we want to take this expression. Now we're going to multiply it times the binomial using lattice multiplication. But let's see, I'm going to put the x plus 2 here. Okay, but I don't need to make the thing 9 terms wide, because I know that some of these have no chance of working, right? Basically, I want everything that contributes to be the x to the 5th term, okay? But like some of these are way too big, right? For example, the two times 8 is 16. X to the 16th, x to the 14th, x to the 12th. These are too big. They're never going to be x to the 5th, right? 10th, 8th, 6th. These are too big. Oh, now we're getting somewhere. So this is the 4th, this is the 2nd, and this is the 0th. Okay, so this one has a chance of working. This one has a chance of working. X to the 6th is already too big, right? Because if I multiply x times x to the 6th times either of these, it's not x to the 6th anymore, right? So the only ones I'm going to write down are like, these two, I guess. All right, so I only need to write down these two. So I'm going to have 8 chooses 6, x to the 4th. And I'm going to have 8 chooses 7 x squared. And I don't think I even need this one, because if I have a constant term and I multiply it times these, I'm not getting x to the 5th either. Okay, so let me now multiply. So if I'm going to multiply this times this, I would get 8 chooses 6, x to the 4th times x, which would be x to the 5th. That looks good, doesn't it? If I multiply this times this, I would get 8 chooses 6, x to the 4th, and times 2, right? Okay, and then this times this would be 8 chooses 7, x to the 3rd. And then this times this would be 8 chooses 7 times 2, x squared. Okay, so we want to know the x to the 5th term. You know, most of these are not x to the 5th. This is to the 3rd, this is the 2nd, this is to the 4th. This is the only one that is x to the 5th, right? And we know that any of the other bigger powers, like this one here, x to the 6th, that wouldn't have been x to the 5th either, because if you multiply it times x and 2, it'll just be x to the 6th, x to the 7th, right? So we're left with only this. This is our only term. So now, just by you know, thinking a little bit, we've eliminated everything that's higher order than this. So like everything that's up here, we eliminated because there's too high order. The exponents are too high. And then we just put everything below and we multiplied it out, and we saw that there was only one of 4 terms that actually works. So we just need to do 8 chooses 6. So let's do that. Oh, and yeah, 8 chooses 6. 8 chooses 6. So it would be 8 math chooses 6. And it'd be 28. So our answer is 28. The coefficient is 28. All right. Now, if you don't see that, you could write out the whole thing here. You know, make the thing, you know, 8 terms or 9 terms wide, right? Don't expand it out. Just write 8 chooses 6, 8 chooses 7, etc. And then when you do that, then you'll be able to see that, oh yeah, like, you know, the x, this would be x to the 5th. It's the only one that's going to be x to the 5th, and that's what we want, right? Another thing about this grid that we just made, do you notice that when I do the diagonals, they don't have like terms? X to the 3rd, x to the 4th, it doesn't line up. Last time when we lined it up, these had the same degree. But it doesn't happen because, like, see, I don't have descending degrees here by 1. I have 2 steps here. So that's why it doesn't work out. Still, it's a useful way of organizing. Maybe you can't do the combined by like terms just by, you know, doing simple diagonals, but you could create some other patterns. Okay? So that was that one. Kind of challenging.